Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. On this channel, you can expect to hear about all things related to process heating, but sometimes the topics aren't technical, but most of the time they are. So thanks for joining. Today, I want to take you back to the basics a little bit. Let's just talk about the major components of a fire heater. So the heart of the heater, what I call the engine of the heater, is going to be the burner. Right? It's providing the heat input. Your goal here is to heat the process fluid. That's what everyone's goal is in a fire heater. And so the process fluid comes in at the coldest part of the heater. This is called counter current flow, meaning I've got cold process coming in and leaving as hot flue gas goes this way. And so conversely, at the hot end of the heater, which is at the burner, this is where my process comes out. So you can see how it's counter current. That's the most efficient way to heat a fluid. So back to the beginning of the heater, I've got a burner. It's firing into this combustion chamber, which is known as the radiant box. This is where radiant heat transfer takes place. A typical temperature in here, a high temperature might be somewhere like 2200 degrees in that flame zone. Outside of the flame zone, it can be quite a bit cooler. Maybe it's 1400 degrees. But either way, that's a really high temperature. So think about what we're doing with a fire heater. We're taking a flammable fluid, we're putting it in a pipe, and we're passing it through areas of a chamber with 2200 degree gases on one side, and inside of the pipe, I've got flammable material, and it will be under pressure. So you want to do a heater right. You want to design it right. That the best way to do it is in two major sections, a radiant section and a convection section. Those are if you were to distill it down, you got a radiant box and a convection box. You got radiant heat transfer and you got convection heat transfer. It just so happens that it's also a good place to break the assembly apart. So there's going to be a field joint right where this convection box bolts to the radiant box. So when we ship this assembly, along with the burner management skid, right here, it's going to come in one piece. Convection box, it's a box with a bunch of pipes in it, right? Where heat transfer occurs as the flue gas flows through that box and adds heat to the process in the convection box. So one of the things you might be wondering is, okay, why do they do it this way? What if we just did a radiant box? Why don't we just do this? Just skip the convection section. Just have a burner here with a long flame. Well, as the name implies, this is radiant heat transfer. So as these gases get lower and lower in temperature, let's say they're 1000 degrees here, my radiant heat transfer gets really lousy. It's just not great heat transfer. Maybe the best I'm going to get is maybe around 1000 degrees if I just try to do it all with radiation. Well, that's a lot of energy leaving if this is 1000 degree gases. So it obviously lends itself to putting a convection section. This is obviously, kind of a hybrid design in here to drop this down and get it down to 500 degrees or lower. The other question is, well, why mess around with a radiant box? Why not just immediately go have a convection box and then a combustion chamber here? Just skip the radiant box. This is all convection, 100% convection. Well, if I operate a burner at, let's say, 3% oxygen here, and I don't take any heat out of that, this temperature gets to be like 3000 degrees. Now, what do you think happens if I put 3000 degrees over a tube with some fins on it? Well, bad things happen. Things go south in a hurry. Now you say, well, I've heard of convection-only heaters. Well, you can do it, but you have to run not 3% O2, you got to run like 12% O2. This isn't real efficient, and so this isn't a great way to do it. So both of these scenarios point us back to, hey, the guys that figured this out 50 years ago were pretty smart and they got it right. So in summary, two major pieces are radiant box, convection box. Those are the two major pieces. And obviously the burner is the engine of this drive that drives this whole thing, providing the heat. And the rest is just to take care of the flue gas as it leaves. Hey, thanks for joining. If you enjoyed this episode, hit like or subscribe to get more information about process heating and Tulsa Heaters Midstream.